So imagine you hand your chief financial officer a mission-critical revenue report, and the primary column is labeled something like cust_id_fin_89.
Oh, they would absolutely look at you like you are speaking some kind of alien language.
Right, like completely lost. Well, today, we are tearing down that wall between rigid database architecture and human readability. So, welcome to the deep dive.
Yeah, glad to be here. We have a lot of really interesting ground to cover today.
We really do. We are looking at datok E12 today, specifically focusing on the schema architecture and data governance in their create and legend modules.
Which I know data governance usually sounds like, well, the broccoli of the tech world.
Exactly. It's the vegetables you have to eat. But today, we are dipping that broccoli in cheese and making it fun. We've got a stack of datok Internal Help Center documentation and some really detailed visual interface screenshots.
And there's a lot of nuance in those screenshots if you know what to look for.
Oh, for sure. So our mission for you today is to shortcut your learning curve. Whether you are prepping for a system architecture meeting or, you are just insanely curious about modern data workflows, we're going to explore how to build resilient local databases and map them to business glossaries.
And most importantly, how to do all of that without alienating your entire team.
Yes, exactly. Because, it is a fascinating dynamic to explore. You are constantly balancing two opposing forces, right?
Oh, absolutely. The computer needs this absolute unforgiving mathematical structure just to operate efficiently. But the human business operator, they need fluidity, context, and plain language.
Yeah, and bridging that gap is notoriously difficult.
It really is.
Okay, let's unpack this. Looking at the Create module, which is where you initialize your SQLite databases instead of your table schema basics, datok clearly prioritizes the computer's needs first.
They absolutely do. It's like pouring the digital concrete for a house. If that foundation is wobbly, everything built on top of it is just going to collapse.
Right. But I have to push back immediately on some of these initial rules.
Oh, what caught your eye?
Well, the documentation dictates that when you initialize a new database, the file name must end in .sqlite, .db, or .sqlite3, which, okay, fine, standard stuff.
Right, pretty standard file extensions.
But then it states the database name can only contain alphanumeric characters, dashes, or underscores. Spaces and special characters are strictly blocked.
Ah, yes. The strict naming conventions.
Wait, we are well into the 2020s here. We
Right.
still cannot use a space in a file name. That feels like, I don't know, a massive step backward for user experience. Why be so draconian about it?
What's fascinating here is that it is not about the year at all. It is about the mechanics of the underlying operating system and the storage model.
Okay, how so?
Well, you have to understand that datok operates entirely on your local machine. It uses browser-native OPFS storage, which is the origin private file system, and saves physical files directly to your local documents folder.
Right, it's not sitting on some Clyde server somewhere.
Exactly. So when you allow spaces or special characters in file names or table structures locally, you introduce a massive variable into command line interfaces and basic file system APIs.
Okay, the system might interpret the space as a delimiter. Like it thinks it's a new command.
You nailed it. If a backend parsing script is not perfectly escaped, it sees a space and assumes you are passing two separate arguments instead of one continuous file name.
Yikes. So it just breaks.
The script breaks, the reader-write fails, and you get a catastrophic error. By enforcing strict alphanumeric rules at the very beginning, datok is effectively idiot-proofing the local file path. Think of it like standardizing shipping containers in the logistics industry.
Well, that's a good analogy. Like the cranes at the port can only grip specific standardized corners.
Exactly.
If you build a container with custom dimensions just because you think it looks nice, the crane cannot lift it, and the whole supply chain just stops.
Precisely. Those strict rules are the standardized dimensions. datok forces you to build a perfect shipping container so its back-end engines can move your data around flawlessly, especially within that OPFS architecture.
Okay, so we have to play by the rules before we even get to the data.
Yes, no exceptions.
And speaking of the data, the Create module requires you to define data types for your columns using standard storage classes. Things like, integer, real, text-t, and blob.
Right, the fundamental building blocks.
But here's where I am a bit confused. SQLite is famous for using a dynamic type system. It's incredibly flexible.
It is very flexible, yeah.
So why does datok force you to declare a rigid schema up front, if the underlying database engine doesn't strictly require it.
Well, because flexibility at the foundation usually leads to total chaos downstream.
Oh, really?
Yeah. While Squalite uses type affinity and can dynamically adjust, declaring these standard types in the schema establishes a strict contract for your architecture.
A contract.
Yeah, a data contract. If you declare a column as an integer, you're telling every subsequent pipeline, dashboard, and machine learning model exactly what format of data to expect.
Ah, I see. So you are preventing data pollution before it even starts. Like, if someone tries to inject a text string into a financial calculation column, the contract just rejects it.
Right, it bounces right off. And there is one structural constraint the documentation highly recommends that ties directly into performance.
Oh, the primary key thing.
Yes, they state a table should have exactly one primary key column, usually named id, and set to the integer data type.
I noticed that in the docs. But why a dedicated explicit ID column? If I'm writing queries, I can just rely on the internal row identifier, right?
Yeah.
Why go through the trouble?
Relying on generic row identifiers is super dangerous if records are ever deleted or moved. But more importantly, declaring an explicit primary key triggers a critical mechanism in the database engine.
Well, mechanism.
It automatically builds a database index on that column.
Oh, okay. And for a local architecture, how does that index change the game?
Well, think about how queries work. When you query an unindexed table, the database has to perform a full table scan.
Meaning it reads everything.
Literally everything. It physically reads every single row on your hard drive until it finds what it is looking for. That is incredibly slow.
Right. That sounds agonizingly slow.
But when datok builds an index on your integer primary key, it generates a B-tree data structure. So instead of a linear scan, the engine traverses the tree mathematically.
So it bypasses the hardware bottleneck entirely.
Exactly. It does not matter if your local solid-state drive is a bit older or slower, because the logarithmic retrieval of the B-tree finds the record in milliseconds.
That is wild.
Yeah.
You are basically optimizing the architecture for the specific limitations of local hardware.
That's exactly what you're doing, yeah.
Okay, so we have poured our concrete. We have our perfectly engineered shipping container. We have strict file extensions, zero spaces, declared data contracts, and a B-tree indexed primary key.
Sounds like a solid foundation.
It is. We have built a phenomenally fast, technically perfect database. But that perfectly structured database creates a massive new problem.
The human element.
Yes. You have just alienated your entire business team. If I hand an operations manager a table filled with column headers like cust_id_a fin, they literally cannot do their job.
Which is the exact problem the Legend module is designed to solve.
Right, because a rigid database is useless if nobody can read it.
If we connect this to the bigger picture, a database is fundamentally useless if the business team trying to extract value from it cannot understand what the fields actually mean. You have to build a translation layer.
And looking at the interface screenshots for the Legend module, that translation layer is surprisingly elegant. It handles business glossaries, metadata mapping, and data stewardship.
It's very clean.
The standout feature here, though, is definitely the one called nice names.
Ah, yes, the alias mapping. It's a game changer.
Right. It replaces the technical jargon with descriptive business terms. The visual we have from the source shows the origin table as sales_transactions.
Classic rigid naming.
Exactly. And the technical field name is transaction_ided. But the nice name is mapped as transaction ID with proper capitalization and an actual space.
And what is crucial to understand here is the mechanism behind that mapping. You are not altering the underlying Squiflate schema at all.
Oh, so the shipping container stays intact.
That perfectly engineered shipping container stays exactly the same. The back-end engine still queries the rigid underscored technical name to maintain its speed and integrity.
But the front-end user interface just renders the nice name.
Exactly.
Yeah.
It is a virtual lens. The computer gets the syntax it demands, and the human gets the context they require. It completely democratizes the data without compromising the engineering.
I love that. And the context goes way deeper than just a title, right? The Legend module features a detailed description field where you can document calculations, business logic, and historical context for that specific column.
It's basically a markdown editor right there in the cell.
Yes, but there is a very specific keyboard shortcut highlighted in the documentation that caught my eye. To insert line breaks and format lists in the description box, you have to use Shift plus Enter.
Ah, the multi-line formatting trick.
Yeah. Why would a simple keyboard shortcut take up valuable space in technical documentation?
Because it solves one of the most infuriating user experience problems in web-based data entry.
Really? How so?
Well, in the document object model, or DOM, of a web interface, hitting the standard enter key inside a form usually triggers a specific event listener.
Like submitting the form.
Exactly. It either submits the entire form prematurely or it triggers a blur event that pulls your cursor focus out of the text box entirely.
Which means you were constantly accidentally exiting the field when you just wanted to, like, start a new paragraph?
It drives users absolutely crazy. I've seen people lose paragraphs of work.
That is the worst.
So, by explicitly programming a Shift plus Enter escape command for multi-line markdown formatting, datok is acknowledging the reality of data entry. It is a defensive design choice. They are protecting the user's workflow from the browser's default behavior.
That is such a smart level of defensive design. I love it.
Right.
But I want to pivot to the actual content of these glossaries for a second.
Sure, let's get into it.
Because Legend requires you to assign 3 critical governance tags to this metadata: the domain, the steward, and the expert.
The accountability framework.
Right. And representing everyone who has ever worked in a massive enterprise, I have to ask, is this cataloging just corporate busy work? Like, who is actually keeping these tags updated?
I hear that all the time. But it only feels like busy work until something breaks.
Fair point.
The governance tags are an accountability matrix. The domain simply categorizes the column functionally, like grouping it into finance or logistics.
Pretty standard cataloging.
Right. But the steward and the expert solve the classic corporate nightmare of the frantic Friday afternoon email blast.
Oh, I know that email. When a metric looks wrong on a dashboard and literally nobody knows who actually owns the underlying data.
Exactly. You're just CCing half the company hoping someone responds.
Yes. So how do these tags fix that?
Well, the steward is the designated data owner who is personally responsible for the accuracy of the attribute. If the data pipeline fails, or the values suddenly turn up null, the steward is the one on the hook to fix the plumbing.
Personal responsibility in data architecture is a rare thing.
Yeah.
I like that. But then how is the expert different from the steward? Why do we need both?
Because fixing the data and understanding the data are 2 entirely different skill sets.
Oh, I see.
The steward owns the data quality, but the expert is the subject matter authority consulted for domain-specific questions.
Okay, let me see if I have this right. The steward is essentially the plumber. They make sure the pipes are connected, the pressure is good, and nothing is leaking.
I like where this is going.
But the expert is like the water sommelier. They cannot fix the pipe to save their life, but they can tell you exactly what the water tastes like, where it came from, and why it has a specific mineral content.
That is a brilliant analogy, yes. The steward ensures the technical accuracy of the customer financial identifier, while the expert can explain the nuanced business rule that calculates that identifier in the first place. You go to them for entirely different problems.
That makes total sense. Now, while we are talking about the Legend interface, there is a tiny detail in the spreadsheet view that I found fascinating.
Oh, what did you spot?
When you were resizing the column headers in the glossary,
Yeah.
Dragging the borders back and forth to fit your screen.
Yeah, pretty standard spreadsheet behavior.
Right, but there is an absolute minimum width limit of 80 pixels.
Ah, another great example of defensive design boundaries.
Right, like you can drag it left, but it just hits a wall at 80 pixels. It's physically impossible to collapse a column into oblivion.
Which is such a relief.
It seems so minor, but anyone who has accidentally hidden a crucial column in a massive spreadsheet and spent 10 minutes trying to unhide it knows the pain.
It really speaks to a cohesive design philosophy across the entire platform. Whether it is the strict alphanumeric file naming rules in the Create module or an 80-pixel visual limit in the Legend module, the goal is the same.
Provide strict boundaries.
Yes, provide strict, unbreakable boundaries so the user is protected from their own accidental mistakes.
Here is where this entire architecture gets really interesting to me. We just discussed initializing complex SQLite tables, configuring B-tree indexed primary keys, mapping virtual alias layers, and building robust accountability matrices.
That's a lot of computing power.
Exactly. In almost any other modern tech stack, all of this computation and storage would be happening on a centralized cloud server.
Oh, it is the default assumption in enterprise tech today. Massive cloud data lakes hosted by third-party providers.
But the sources emphasize a massive differentiator for datok. This is a 100% local architecture.
Completely low.
There are no remote cloud servers. The active datasets and the entire graphical interface operate inside your local browser tab sandbox memory. And the physical databases are saved directly to your local hard drive via that OPFS storage we mentioned.
Right, the origin private file system.
The documentation explicitly lists the path, too. It's your local C drive, inside the user's folder, under your username, into the documents folder, and finally the datok folder.
This raises an important question, though, because it fundamentally shifts the performance constraints.
How so?
Well, when you rely on a cloud server, your bottleneck is your external internet bandwidth and the server's compute quota. But here, your processing speed is tied entirely to your own hardware.
Right, because there's no cloud compute to lean on. So what happens if I try to push the limit? Say I load a massive data set, like 50 million rows, into the Legend module on an old, underpowered laptop.
You are going to hit the limits of the browser's JavaScript engine memory allocation pretty fast.
Meaning the tab crashes.
Yeah. The browser tab enforces a maximum heap size for its sandbox, usually somewhere between 1.5 to 4 gigabytes, depending on your system architecture.
Right.
If you load 50 million rows into the active interface and exceed that memory limit, the browser tab will crash. You will get an out-of-memory error.
Ouch. But what happens to my physical Squalite database on the C drive? Does the crash corrupt the file?
No, and that is the beauty of separating the execution sandbox from the physical OPFS storage.
Oh, thank goodness.
Yeah, the crash only happens in the browser's volatile memory. The physical bytes on your local disk are completely safe because the transaction was not actively writing to the disk during the memory overflow.
That is a phenomenal trade-off.
Yeah.
You are sacrificing infinite cloud compute scale, but in return, you get absolute unconditional data privacy.
Exactly. It's a huge win for privacy.
You never have to worry about data quotas, and you never have to worry about a cloud provider being breached because the data literally never leaves your physical machine.
It is the ultimate security model for sensitive financial or healthcare data.
And to make sure that local experience actually feels seamless, the Legend module employs some incredibly aggressive autosave mechanics. The documentation refers to it as a focus out trigger.
Ah, yeah. In web development, that is known as a blur event.
Let's break down the mechanics of that. When I am typing my markdown description and I finish and click onto the next row, my cursor loses focus on the original field. That is the blur event.
Correct. The browser's event listener detects that the input field has lost focus. The moment that happens, it triggers a function that instantly writes the change to the backend database.
And because the backend is literally sitting on my local C drive, that write operation happens instantaneously.
There is zero latency.
Right. I do not have to wait for a server halfway across the world to acknowledge the packet.
It is immediate. You never have to hunt for a save icon. And crucially, every single time that blur event fires, it automatically updates a last edited timestamp column in the metadata.
Oh, wow. The ultimate audit trail.
Exactly. You always know exactly when a steward or an expert last updated the glossary definition down to the absolute second. It reinforces that accountability matrix we talked about earlier.
So what does this all mean? Let's step back and look at the whole picture. We have unpacked a seriously impressive system today.
We really have covered a lot of ground.
We started in the Create module, where we learned why localized operating systems demand rigid alphanumeric foundations and how establishing strict data contracts and index primary keys bypasses local hardware limitations.
Then we transition to the Legend module, which serves as the critical translation layer.
Right, the human side of things.
Exactly. It humanizes that rigid data with nice names, uses defensive design like Shift plus Enter and 80 pixel limits to protect the user experience, and enforces accountability through domain, steward, and expert tags.
And we discovered that all of this operates within an architecture of absolute privacy. No cloud servers, just the boundaries of your local browser sandbox and the speed of your local hard drive through OPFS, guarded by instant blur event autosaves.
It's a very unique approach.
It is. Understanding the mechanics of these two modules really is the ultimate shortcut.
Yeah.
Gives you the tools to bridge the massive gap between IT's absolute need for structure and the business team's absolute need for clarity.
It is a profound shift in how we handle information. But, I want to leave you with one final thought to mull over, looking at the cultural implications of this architecture.
Okay, I'm intrigued. What's the thought?
Well, we live in an era currently obsessed with centralizing everything, right? Uploading every single byte of corporate data to massive, faceless cloud lakes.
Very true.
But datok is pushing in the exact opposite direction. What happens to a company's culture when you start distributing highly governed, fully private data pods directly to individual employees' local machines?
Oh, that's an interesting angle.
If we rely on the Legend module to make individuals personally accountable as stewards, does giving those employees physical, localized ownership of their databases actually make them fiercely protective of their data quality?
Wow. Does holding the physical keys to the vault change how you treat the gold inside? That is a fascinating question to chew on.
I think it does.
Well, next time you are staring at a chaotic spreadsheet or a database column named with 12 underscores, remember that understanding the mechanism beneath it can change everything. Thanks for joining us on this deep dive. Keep exploring, keep questioning, and we will see you next time.